Today we're going to be talking about section 10.5, which is on tangents. Now, tangents are a line that touches a figure at only one point. So if you look at this example over here, line AB touches circle C at only one point, and that's point A. So that point A has a special name called the point of tangency. Now, you can have something called a common tangent, and that's when one line is tangent to multiple figures. So for example, circle F and circle G are both tangent to line L. And so then line L would be a common tangent between F and G. Now example 1, right here, it says, show if there's a common tangent between these two. If no common tangent, then write no common tangent. So if you look at this one right here, what I could do is I could draw a circle or a line on these circles so it hits at only one point here. That's a line of tangency or common tangent. I could also do the same. Now, that was a bad picture, but essentially you'll see right there, it's going to hit it those 2 points right there. Now, I could not draw it right here through here, even though it touches both circles. Notice it touches the smaller circle at 2 points instead of just 1. So those are the 2 common tangents. Now, again, the same thing. I could do the exact same right here. Okay? Same thing. Common tangent right there. Hits at only 1 point on both circles. Okay? Very good. Alright, theorem 10.10. It says, in a plane, a line is tangent to a circle if and only if it is perpendicular to the radius and the drawn point of tangency. So essentially what it's saying is any tangent that you draw on a circle is going to be perpendicular to the radius. It's always going to form a 90-degree angle. So if we look at example 2, it says JL is the radius of circle J. And notice it's 8. Determine whether KL is tangent to J. Justify your answer. So we're going to look at this triangle individually. We're going to see if L right here is a right angle. So if I look, this value right here is also 8 because it's the radius. So the whole hypotenuse of my triangle is 17. Now, Pythagorean theorem says that if you have 3 sides of a triangle, if it fits in the Pythagorean theorem, then it is a right triangle. So we're going to try that. So a squared plus b squared equals c squared. Okay? And we'll just plug in the values. Remember, c has to be 17. And I always like the smaller one as a, so that'd be 8 squared, and then 15 squared. So just plug those numbers in. So 8 squared is 64, plus 15 squared is 225, 17 squared is 289. Let's just see if they add up. 64 plus 225 is going to be 289. So notice it works in the Pythagorean theorem, so this is a right triangle. So determine if KL is tangent to it. KL is tangent since angle L is 90 degrees. Okay. Here's another example in the guided practice. You can try to see if GH is tangent to that triangle. Alright. Example 3. Use a tangent to find a missing value. It says JH is tangent to angle G, or circle G, at J. Find the value of X. So, this is X, okay? This is X plus 8, and then my other side is 12. So again, it's going to work in the Pythagorean theorem. So we'll just plug in our numbers. So we're going to say X squared plus 12 squared is going to be equal to X plus 8 squared. Okay? Now, this part right here might look a little confusing, might look a little tricky. I'll go over the multiplication. You'll have to remember back to algebra to remember how to do that, but we'll do it real quick. So X squared plus 144 is equal to, and X plus 8 squared is the same as X plus 8 times X plus 8. Again, it's going to be something we'll look back at in algebra 2. So X plus X, or X times X is X squared. Okay, the middle part, 64 at the end. Okay, and then 8x plus 8x is going to be 16x. Okay? So, I set this all up. Okay? I did all this. So what I'm going to do then is I'm going to subtract x squared from both sides. Notice those go away. Alright? I also see that I get 144 is equal to 16x plus 64. I can subtract 64 from both sides. And I end up getting 80 is equal to 16x divided by 16. And you find that x equals 5. We could do the exact same in these guided practice problems as well. Alright, so theorem 1011 says this: if two segments from the exact same exterior point are tangent to a circle, then they are congruent. So it says right here, AB and CB are tangent to D. That means that this line and this line are the same. So let's look at example 4. It says use congruent triangles to find the missing measure. Well, you'll see that since AB and CB are tangent to, and they have some common point B, that means that the two sides are equal to each other. So x plus 15 is going to be the same as 2x minus 5. And so it's just a moron problem, and I can move all the x's to one side. I'm going to move them to the right. Right? Add 5 to both sides, and you find that x equals 20. There's my value of x. Notice that's all they're asking for. They're not asking for how long AB or CB are. They're just asking for the value of x, which is 20. Again, here's some guided practice problems you can try as well. Now, circumscribed polygons are polygons that are circumscribed about a circle and every side which is tangent to our polygon. So let's look at an example like that. It says a graphic designer is giving directions to create a large version of the triangle logo shown below. If AB and C is circumscribed about circle G, find the perimeter of ABC. Okay, so the first thing we see right here is that CB is 10. Okay, that's already listed for us. We also see that AD and AE would be perpendicular. So congruent. So that means that this value right here is 8. So this whole side right here, 8 and 7 would be 15. Now here comes the tricky part. Okay? Here comes the trickier part. So we know we're looking for this side right here. That's our question mark. We know everything else, but that's the one side we don't know. But we see that this is 7, and so this has to be 7. Okay? And if the whole thing is 10, then this missing side would be 3, which means that this question mark we have is 3 as well. So then this side over here, 8 and 3, would be 11. So now how do we find the perimeter? We just add up all the sides. So 10 plus 11 plus 15 is going to be equal to 36